Okay, we're going to talk about going from moles to atoms and atoms to moles. We need to use this relationship, which is Avogadro's number, 1 mole atoms equals 6.022 times 10 to the 23rd atoms. So if we had 1 mole of carbon, we would say that is equal to 6.022 times 10 to the power 23 carbon atoms, or atoms of carbon, either way you want to say it. We had a mole of lead. It would be equal to 6.022 times 10 to the power 23 lead atoms. So this would work for any element, any atom. Any atom, I'm just giving a generalization of X. So I'm going to use copper as an example. You don't have to worry about memorizing Avogadro's number because it will be given to you on the exam. You just need to know how to use it. So, calculate the number of copper atoms in 2.54 moles of copper. So the first thing we need to do is we need to write out our equivalency or our equation. 1 mole of copper is equal to 6.022 times 10 to 23rd copper atoms. Now, since we have this equivalency, we can write our fractional ratios just like we did when we did conversion factors. 1 mole of Cu over 6.022 times 10 to 23rd Cu atoms, and we can write 6.022 times 10 to the power 23 atom Cu atoms over 1 mole of copper. We can get these two relationships from this one equation. So if we want to go from moles to atoms, we would use this because we need moles to cancel in denominator. If we want to go from atoms to moles, we would use this one because copper atoms would cancel here in denominator. So let's just work out this problem. So calculate the number of copper atoms in 2.54 moles of copper. So we would have 2.45 moles of copper. Now that's what we're given. So we know that 1 mole of any atom, in this case we're going to choose copper, is equal to 6.022 times 10 to the power of 23 copper atoms. Okay, so I want to convert that mole of copper to atoms of copper. So I need to use this relationship. I need to say that 1 mole of copper in the denominator and 6.022 times 10 to the power of 23 copper atoms in the numerator. So what happens here is moles of copper and moles of copper cancel. So I'm left with a unit of copper atoms. So when I multiply 2.45 times 6.022 times 10 to the power of 23, I get 1.48 times 10 to the power of 24 copper atoms. So I've just went from moles of copper to atoms of copper. Now, let's see what would happen if we wanted to calculate the number of moles of copper in let's just say 14.75 times 10 to the power of 21 copper atoms. Let's just say we wanted to calculate the number of moles present in this number of atoms. So, erase this down at the bottom. So now we're going from atoms of copper to moles of copper. So we would use these same two relationships, but we're going from atoms to moles, so we need the relationship that allows atoms to cancel in the denominator with the atoms in the numerator. So this is a relationship we have here. So we would say 14.75 times 10 to the power of 21 copper atoms times what? We will use this relationship. We want to get moles, so we put moles in the numerator, and we put atoms in the denominator. So this would be copper atoms. So what happens here? My unit of copper atoms cancels, and that is equal to, put this in parentheses, group that together. That would be 4.14.75 times 10 to the power of 21 times 1 divided by 6.022 times 10 to the power of 23. So I don't have my calculator with me right now, so I'll let you solve that for yourself. This is 10 to the power of 21. This comes in the numerator, will become minus 23. So we would have a small number. We should have a small number. So I will let you do that. And also, I want to emphasize that you practice the examples in the text book and review class notes on this subject.